Welcome to vectors. Let's consider a situation with vectors where we want to find the resultant and we're going to use the trig method. So we have an airplane that flies 1,600 miles west from Cincinnati to Salt Lake City and then 500 miles south to Phoenix. The first thing we're going to do is we're going to draw a diagram. So we have two vectors, 1,600 miles west, and then our second vector 500 miles south. Okay, so I'm going west and south. I'm going to draw coordinate axis, which is my starting point. And then I'm going to start out with a longer vector to the west and label that 1,600 miles. And then head to tail, one continuous path. I'm going to start the next vector right here. And I'm going to go 500 miles to the south. So, shorter vector than the first one. And then the resultant will be how far or where we've gone from start to finish. So that is the resultant. Now, these two vectors, south and west, form a right angle. And as long as they form a right angle, we can use your normal trig functions and Pythagorean theorem. So we can find r directly by r squared equals 500 squared plus 1,600 squared. So that's going to give us an r value of 1676.31 miles. To find the angle, it's always the angle by the starting point. We want to know where we have gone relative to that starting point. So I'm going to label theta on my diagram. And then from theta, we know the opposite side and the adjacent side. Opposite and adjacent, that's tangent. So I can use tangent of theta, and that's going to be equal to 500 divided by 1,600. So that's going to give me a theta value of 17.35 degrees. Now, to state the final answer, a vector is both a magnitude and a direction. So r is equal to 1676.31 miles at 17.35 degrees, but then we need to describe the direction. The direction, the first side of the angle starts at west, and from west we rotate toward the south. So south from west or south of west. So if you have a situation where you have the vectors forming a right angle, you can go straight to Pythagorean theorem and the trig functions. Now, in part B, some different things happen. The plane gets diverted, so it still flies from Cincinnati to Salt Lake City, but then it gets diverted, and instead of flies from Salt Lake City to Los Angeles, 690 miles at 32 degrees south of west. So then, changing things a little bit, I'm going to need the whole board, so I'm going to erase. So then our 500 miles south is gone. And so now in part B, instead, we are going 690 miles, and that's at 32 degrees south of west. So now we're going to proceed in the same fashion. We're going to start by drawing the two vectors head to tail. So I'm going to draw my starting point. And then 1,600 miles west. Now, the next vector is at an angle, so we want to go south of west. So here I am at the end of this vector. I'm going to continue on. There's my west reference line, and now I want to go south of there. So I'm going to rotate 32 degrees toward the south from there. And that's where I'm going to draw my second vector. 690 miles south of west. So now my resultant, where I am from my starting point, would be right there. Now notice on your triangle, this is not a right triangle, If it's not a right triangle, you cannot use the trig functions in Pythagorean theorem unless you want to get the wrong answer. The trig functions do not apply to non-right triangles. So then what we need to do is that we need to basically make this into a right triangle. So then we need R to be a hypotenuse. If we need R to be a hypotenuse, then we would need to picture a right angle would be somewhere over here in this neighborhood. So if I extend here and there's a right angle of a triangle where R would be the hypotenuse. So then before we can use that large right triangle, we need to do a little bit of trig here on the little right triangle where the 690 is the hypotenuse. So then I'm going to call this x1 and y1 and do a little bit of trig to find those two pieces. Cosine of 32 degrees adjacent x1 over hypotenuse 690. Sine of 32 degrees opposite, which would be y1 over hypotenuse 690. So then if we calculate those two values, x1 comes out to be 585.15 miles, and y1 comes out to be 365.64 miles. So now, if we think of these up here in our diagram, this is 585.15, and this one is 365.64, kind of squeezing things in. I can add the values here together to get that whole side, and then the y only has a single value. So then if I redraw my entire figure, so here is the same R that I drew right there. Now this side is going to be the total of these two sides, so that's going to give me 2,185.15 miles when I add the 565.15 and the 1,600. This side is going to be the 365.64. Now, we started with something that was not a right triangle, and we did a little bit of trig to make it into a right triangle. So from here, now I can use Pythagorean theorem. The angle I'll need to find there is theta, and I can use trig functions to find that. So r squared is equal to 365.64 squared plus 2185.15 squared, and then tangent theta is equal to opposite 365.64 over adjacent 2185.15. When we solve down, we get an R value of 2215.53 miles at 9.5 degrees, and this would be starting at west, rotating south, so this would be south from west or south of west. So, in summary, when you have a trig problem or a vector problem, when you don't start out with a triangle or don't start out with a right triangle, then you're going to have to picture your resultant as a hypotenuse, find the components of vectors to combine to make a right triangle, and then you're able to use the normal trig. Ponder physics.